Cable trays are indeed permissible for use in residential work, including in the basement, for running range, dryer, and other power wiring along an unfinished ceiling. They offer a structured and organized approach to managing electrical cables. Consider the National Electrical Code or NEC requirements for cable tray installations. Article 392 covers cable trays. The NEC doesn't specifically prohibit their use in residential settings, provided all applicable requirements are met. These requirements relate to things like support, grounding, fill capacity, and cable securing. Firstly, ensure the cable tray is adequately supported. The support intervals will depend on the manufacturer's specifications and the type of cable tray used, such as ladder, ventilated trough, or solid bottom. Refer to NEC Article 392.30 for support requirements. Secondly, grounding of the cable tray is essential. Cable trays must be properly grounded to provide a low impedance path for fault currents. This grounding ensures safety and helps prevent electrical shock hazards. See NEC Article 392.60 for grounding requirements. Thirdly, cable fill should be considered. Do not overload the cable tray with too many cables. Overfilling can lead to overheating and difficulty in accessing or maintaining the cables. NEC Article 392.22 specifies cable fill requirements for cable trays. Fourthly, proper cable securing is necessary. Cables must be securely fastened to the cable tray to prevent them from sagging or becoming damaged. Use appropriate cable ties or clamps designed for cable tray applications. Fifthly, consider the type of cables being run in the cable tray. Ensure that the cables are rated for the intended application and environment, including temperature and moisture conditions. Use the correct type of cable, such as type NMB for general wiring, or type SC cable for service entrance wiring. Sixthly, check for any local codes or regulations that may have additional requirements or restrictions on the use of cable trays in residential applications. Local jurisdictions may have amendments to the NEC that are important to follow. Seventhly, consider the spacing of the cables within the tray to prevent overheating. Eighthly, make sure the cable tray is accessible for future maintenance. Ninthly, use appropriate fittings for connecting sections of cable tray and for transitions to other wiring methods. Tenthly, label the cables and the cable tray to clearly identify circuits and pathways. For a range, dryer, and other power wiring in a basement, cable trays can be a great solution. These appliances typically require dedicated circuits with specific ampacity ratings. For example, a range circuit might require a 50 amps breaker and a 6 American wire gauge, or AUG, copper conductor, while a dryer circuit might require a 30 amps breaker and a 10 AWG copper conductor. Refer to NEC Table 310.16 for allowable ampacities of conductors. The cable tray allows for neat and organized routing of these cables. When selecting a cable tray, consider the load it will need to support, the environment it will be installed in, and the type of cables it will be carrying. Aluminum cable trays are lightweight and corrosion resistant, while steel cable trays are stronger and more durable. Choose the appropriate material based on the specific application. Ensure that the cable tray system is properly bonded and grounded according to NEC Article 250. Use a grounding electrode conductor of the appropriate size, as determined by NEC Table 250.66. The grounding electrode conductor should be connected to a grounding electrode system, such as a ground rod or water pipe. Proper grounding is critical for safety and to prevent electrical shock hazards. When installing cables in the cable tray, follow the manufacturer's instructions and the NEC requirements. Secure the cables to the tray using cable ties or clamps. Do not exceed the fill capacity of the tray, as this can lead to overheating and damage to the cables. Ensure that the cables are properly supported and protected from physical damage. When making connections to appliances, use appropriate wiring methods such as flexible metal conduit, or FMC, or liquid-tight flexible metal conduit, or LFMC. These wiring methods provide mechanical protection for the conductors and allow for some flexibility in connecting to the appliance. Always follow the manufacturer's instructions and the NEC requirements for making electrical connections. Be sure to use properly sized overcurrent protection devices, such as circuit breakers or fuses, to protect the wiring and equipment from overloads and short circuits. Refer to NEC Article 240 for overcurrent protection requirements. The size of the overcurrent protection device should be based on the ampacity of the conductors being protected. For example, a 12 AWG copper conductor is typically protected by a 20 amps breaker. Always use listed and labeled electrical components and equipment. Listed and labeled products have been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories, or all, to meet safety standards. Using listed and labeled products ensures that they are safe and reliable. In addition to the NEC requirements, also consider any local building codes or regulations that may apply to electrical installations in your area. Local codes may have additional requirements or restrictions on the use of cable trays or other wiring methods. Contact your local building department to obtain information on local codes and regulations. When working with electricity, always take safety precautions. Turn off the power to the circuit before working on any electrical components. Use appropriate personal protective equipment, or PPE, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Electricity can be dangerous, and it is important to take all necessary precautions to avoid injury or property damage. Remember to properly size conductors for the intended load. Consult NEC Table 310.16 for ampacity ratings of conductors. The conductor size should be based on the ampacity of the circuit and the type of insulation. For example, a 12 AWG copper conductor with THHN insulation has an ampacity of 20 amps at 75 degrees Celsius. Consider voltage drop when sizing conductors for long runs. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. NEC Informational Note Number 2 to Table 310.16 provides guidance on voltage drop calculations. The recommended voltage drop is 3% for branch circuits and 5% for feeders. Use appropriate conduit fittings and connectors. Conduit fittings and connectors should be listed for the intended use and should be compatible with the type of conduit being used. Ensure that all connections are tight and secure. Use appropriate wire connectors for making splices and terminations. Wire connectors should be listed for the intended use and should be compatible with the type of conductors being connected. Ensure that all connections are tight and secure. Consider using a surge protective device, or SPD, to protect sensitive electronic equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. SPD divert excess voltage to ground, protecting equipment from damage. NEC Article 285 covers surge protective devices. When installing cable trays in a basement, consider the potential for moisture or dampness. Use cable trays that are rated for wet locations or provide adequate drainage to prevent water from accumulating in the tray. Consider using corrosion-resistant materials, such as aluminum or stainless steel for cable trays and hardware. Inspect electrical installations regularly for any signs of damage or deterioration. Replace any damaged or worn components promptly. Keep electrical panels and equipment clean and free of debris. Do not store flammable materials near electrical equipment. Ensure that all electrical work is performed by qualified personnel. Hire a licensed electrician to perform any electrical work that you are not comfortable doing yourself. Obtain all necessary permits and inspections before starting any electrical work. This ensures that the work is done in accordance with applicable codes and regulations. Maintain accurate records of all electrical work performed, including wiring diagrams, equipment specifications, and inspection reports. This information can be helpful for future maintenance and troubleshooting. Consider using energy-efficient lighting and appliances to reduce energy consumption and save money. Energy-efficient products can significantly reduce your electricity bill and help protect the environment. Install ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. GFCIs detect ground faults and quickly shut off the power to prevent electrical shock. NEC Article 210.8 requires GFCI protection in certain locations. Use arc fault circuit interrupters, or SIs, to protect against arc faults, which can cause fires. SIs detect arc faults and quickly shut off the power to prevent fires. NEC Article 210.12 requires SI protection in certain locations. When installing electrical equipment, follow the manufacturer's instructions and the NEC requirements. Ensure that the equipment is properly grounded and protected from overloads and short circuits. Do not overload electrical circuits. Overloading circuits can cause overheating and fires. Determine the load on each circuit and ensure that it does not exceed the ampacity of the circuit. Use a circuit breaker finder to identify circuits quickly and easily. A circuit breaker finder consists of a transmitter and a receiver. The transmitter is plugged into an outlet, and the receiver is used to scan the circuit breaker panel to identify the corresponding breaker. Use a multimeter to measure voltage, current, and resistance in electrical circuits. A multimeter is an essential tool for troubleshooting electrical problems. It can be used to identify open circuits, short circuits, and other electrical faults. Use a wire stripper to remove insulation from wires without damaging the conductors. A wire stripper is a specialized tool that is designed to remove insulation cleanly and efficiently. Use a crimping tool to crimp connectors onto wires. A crimping tool is used to create a secure and reliable connection between a connector and a wire. Use a fish tape to pull wires through conduit. A fish tape is a flexible tool that is used to guide wires through conduit. It is especially useful for long or difficult runs. Use a level to ensure that electrical boxes and equipment are installed level. A level is essential for ensuring that electrical installations are aesthetically pleasing and function properly. Use a stud finder to locate studs in walls for mounting electrical boxes and equipment. A stud finder is a tool that is used to locate studs behind drywall or plaster. It is essential for securely mounting electrical boxes and equipment to walls. Use a voltage tester to verify that a circuit is energized before working on it. A voltage tester is a tool that is used to detect the presence of voltage in a circuit. It is essential for safety when working with electricity. By adhering to these guidelines and consulting the relevant articles and tables in the NEC, you can safely and effectively use cable trays in residential applications for range, dryer, and other power wiring needs, ensuring an organized and compliant electrical system. Always prioritize safety and consult with a qualified electrician if you have any doubts or concerns.